It's everywhere. Hello, future scientists. Are you ready to explore something amazing? Let's talk about chemistry. What is chemistry, you ask? Well, chemistry is the science of stuff. It's all about what things are made of, how these things work, and how they can change. From the biggest star to the smallest bug, chemistry helps us understand it all. It's like a giant puzzle, and we get to find the pieces. Pretty cool, right? Now, you might think chemistry only happens in a fancy lab with scientists in white coats and bubbling potions. Sure, that's part of it. But guess what? Chemistry is happening all around you, all the time. It's in the air you breathe, it's in the water you drink, and it's even in your favorite sandwich. Yes, your peanut butter and jelly sandwich is a chemical wonder. Consider this. When you bake a cake, that's chemistry. When an apple turns brown, that's chemistry. When fireworks light up the night sky, wow, that's chemistry too. Our own bodies are like super complex chemistry sets. Growing, eating, thinking, all powered by chemical reactions. So, you see, chemistry isn't far away. It's right here, right now, making everything happen. It's the science of everyday life. So, get ready to put on your thinking caps. We are going on a chemistry adventure together. We'll look at tiny, tiny particles. We'll see how they make up everything we see. We'll learn about amazing changes. And we'll even talk about experiments you can try. Science is all about asking questions and discovering answers. Let's get started and explore the incredible world of chemistry. Everything around us, everything you can touch, see, or even smell, it's all made of super, super tiny parts. What are these parts called? They are called atoms. Atoms are the basic building blocks of all matter. Imagine a Lego brick. Atoms are like that, but much, much smaller. So small you can't see them with just your eyes. Not even with a regular microscope. You would need billions of atoms just to make the dot on this page. Isn't that mind-blowing? Now, what's inside an atom? It's like a tiny world. In the center of the atom is the nucleus. The nucleus has even smaller bits called protons and neutrons. Protons have a positive charge. Think of it like a plus sign. Neutrons have no charge. They are neutral. Then, zooming around the nucleus are electrons. Electrons are super tiny and have a negative charge, a minus sign. It's like a mini solar system, with electrons orbiting the nucleus. Atoms are mostly empty space, believe it or not. So, atoms are like individual Lego bricks. What happens when these bricks snap together? They form something new called a molecule. A molecule is made when two or more atoms join up. They hold hands, chemically speaking. For example, water. You drink it every day. A water molecule is made of 2 hydrogen atoms and 1 oxygen atom. That's why we call it H2O. These atoms stick together to make one water molecule. Atoms and molecules are never perfectly still. They are always moving, jiggling, and bumping into each other. Even in a solid object like your desk, the atoms are vibrating in place. In liquids, they slide past each other. In gases, they zoom around super fast. This movement is a form of energy. The more they move, the more energy they have. These tiny movers and shakers make our world work. Now that we know about atoms, let's talk about elements. What is an element? It's a pure substance. This means it's made up of only one kind of atom. Think of it like this. If you have a pile of pure gold, all the atoms in that pile are gold atoms. Nothing else. Gold is an element. Oxygen, the gas we breathe to live, is an element too. All its atoms are oxygen atoms. Elements are like the basic ingredients for everything in the universe. Each element is unique and has its own special properties. Some elements are shiny metals like copper or silver. You see copper in wires and silver in jewelry. Other elements are gases you can't even see, like helium, which makes balloons float high in the sky, or neon, which glows bright in colorful signs. Some elements are very common, like carbon. Carbon is in you, in me, in plants, and even in diamonds. Every element behaves in its own special way. Let's think about some elements we use every day. We already mentioned oxygen. Oh, we need it to breathe. Plants make oxygen for us. How cool is that? Then there's hydrogen. H, it's the lightest element. It teams up with oxygen to make water. H2O. Iron, Fe, is a strong metal. It's used to build cars and bridges. Aluminum, Al, is light and strong. It's used for cans and airplanes. Sodium, Na, is a metal that's part of table salt. These are just a few of nature's amazing building blocks. Scientists have discovered over 100 different elements. Most of these elements are found naturally on Earth. Some are found in stars, far away in space. A few very heavy elements are even made by scientists in labs. These human-made elements usually don't last very long, but finding them helps us learn more about atoms. Each element has a name and a special 1 or 2 letter symbol, like O for oxygen or He for helium. It's like an alphabet for all the stuff in the universe. So we have all these elements, over 100 of them. How do scientists keep them all organized? They use a super special chart. It's called the periodic table of elements. Imagine a giant grid, like a calendar, but for elements. Each element gets its own box on this table. It's like a cheat sheet for chemists. It tells them so much about each element and how all the elements relate to each other. It's one of the most important tools in chemistry. How is this amazing table organized? It's very clever. The elements are arranged in order of their atomic number. The atomic number tells us how many protons are in an atom of that element. Hydrogen is first, with 1 proton. Helium is second, with 2 protons, and so on. The table also has rows, called periods, and columns, called groups. Elements in the same group have similar chemical properties. This means they behave in similar ways when they mix with other things. It's like organizing your toys by what they do. Why is the periodic table so important for scientists? Well, it's not just a list, it's a map. It helps scientists understand the patterns in elements. They can predict how an element might behave even before they do an experiment. They can guess if an element will be a solid, liquid, or gas, or if it will be very reactive, meaning it likes to join with other elements, or if it will be calm and not react much at all. This table helps us understand the building blocks of everything. So, take a look at a periodic table sometime. You can find them in science books or online. Each little box on the table is full of information. It shows the element's symbol, its atomic number, and often its atomic mass. Some tables are even color-coded to show different groups like metals, non-metals, and noble gases. The periodic table is a masterpiece of scientific organization. It's a guide to the ingredients that make up our entire universe. Wow, science is organized. Guess what? Your kitchen is actually a chemistry lab. That's right. Every time you cook or bake, you're doing chemistry. Think about baking cookies. It's a delicious experiment. You mix flour, sugar, eggs, and butter. These are your chemicals. Then you put the cookie dough in the hot oven. The heat causes chemical reactions to happen. The ingredients change. They combine in new ways. The cookies spread out, turn brown, and become solid. And they smell so good. That's chemistry you can eat. Have you ever wondered why bread rises and gets all fluffy? It's chemistry at work, thanks to a tiny living thing called yeast. Yeast eats the sugar in the bread dough. As it eats, it produces a gas called carbon dioxide. This gas makes tiny bubbles in the dough. The bubbles get trapped and make the dough expand or rise. When you bake the bread, the heat makes the bubbles bigger, and voila! You have soft, airy bread. Isn't that a neat trick by tiny yeast chemists? What about dissolving sugar in your lemonade or tea? That's a physical change, and chemistry helps us understand it. When you stir sugar into water, the sugar seems to disappear, but it doesn't really go away. The tiny sugar molecules spread out. They fit into the spaces between the water molecules. This creates a sweet mixture called a solution. Chemistry explains how different things mix together, or sometimes why they don't mix, like oil and water. And here's another kitchen chemistry example. Cooking an egg. An uncooked egg white is clear and runny. It's made of proteins, which are long, tangled molecules. When you heat the egg in a pan or in boiling water, the heat energy makes those protein molecules untangle. Then they link together in a new way. This changes the egg white from clear and runny to white and solid. This change is called denaturation. It's irreversible. You can't uncook an egg. That's chemistry for breakfast. Boom! Fizz pop! Understanding chemical reactions. Now for some exciting stuff. Chemical reactions. What exactly is a chemical reaction? It's a process where some substances, called reactants, change into completely new substances, called products. The atoms in the reactants rearrange themselves. They break their old bonds and form new bonds. It's kind of like taking Lego creations apart and then using the same bricks to build something totally different. It's not magic, it's science, and honestly, it's happening everywhere. How can you tell if a chemical reaction is happening? There are some common clues to look for. Sometimes you'll see bubbles forming. That means a gas is being made, like when you mix baking soda and vinegar. Fizz, fizz, fizz. Sometimes there's a color change. An apple turning brown is a sign. A reaction might produce heat or light. Think of a burning candle. or it might get cold. Some reactions actually absorb heat. Sometimes a new solid, called a precipitate, forms in a liquid. Or you might notice a new smell, like cookies baking. Let's look at an everyday chemical reaction, rust. If you leave an iron nail or a bicycle outside in the rain, it might start to get a reddish-brown coating. That's rust. Rust forms when iron Fe reacts with oxygen O2 from the air, and water helps this reaction happen faster. The iron atoms combine with oxygen atoms. They form a new substance called iron oxide, which is rust. This is a slow chemical reaction, but over time it can change shiny iron into crumbly rust. Some chemical reactions are super fast and dramatic, like fireworks. Boom! Sparkle! Wow! Fireworks are carefully designed chemical reactions. Different chemicals are packed inside. When they are lit, they react very quickly. They produce loud sounds, bright light, and beautiful colors. Different metal elements create different colors when they burn. Strontium makes red, barium makes green, copper makes blue. These reactions are powerful. That's why we watch from a safe distance. Chemical reactions can be slow, fast, useful, or just plain spectacular. Science is all about curiosity and discovery. And many amazing scientists called chemists have made huge discoveries. Let's meet a few of these science superstars. One incredible scientist was Marie Curie. She was a pioneer in studying radioactivity. That's when atoms of some elements give off tiny particles and energy. Marie Curie worked very hard, often in a simple lab. She discovered two new elements, polonium and radium. She was the first woman to win a Nobel Prize, and the only person to win Nobel Prizes in two different sciences. Another very important chemist was Dmitri Mendeleev. Remember the periodic table we talked about? He created it. Back in the 1860s, scientists knew about many elements, but there was no good way to organize them. Mendeleev noticed that if he arranged elements by their atomic weight, elements with similar properties appeared at regular intervals, or periods. He even left gaps in his table for elements that hadn't been found yet, and he correctly predicted their properties. What a brilliant mind! His table became the foundation for how we understand elements today. Let's also talk about Antoine Lavoisier. He is often called the father of modern chemistry. He lived in the 1700s in France. Lavoisier did careful experiments, especially with burning. He showed that burning isn't caused by releasing a mysterious substance. Instead, it involves a substance combining with oxygen. He even gave oxygen its name, and hydrogen too. He also showed that mass is conserved in chemical reactions. This means you have the same amount of stuff before and after a reaction. It just gets rearranged. His work changed chemistry forever. These are just a few examples of brilliant chemists. There have been many, many more from all over the world. People like Robert Boyle, who studied gases, or Linus Pauling, who studied chemical bonds. What did all these scientists have in common? They were curious. They asked lots of questions. They observed the world carefully. They did experiments. And they weren't afraid to challenge old ideas. You can be curious and ask questions too. That's how science advances. Are you ready to become a chemist in your own home? There are lots of fun and safe experiments you can do. But remember, always ask a grown-up for help and permission. Safety first. Science is fun, and safe science is even better. Okay, first up, the classic baking soda and vinegar volcano. You'll need baking soda, vinegar, a bottle, and maybe some food coloring. Put some baking soda in the bottle, then pour in the vinegar, and watch the eruption. Foam will bubble up and flow out like lava. This is a chemical reaction. Next, let's make some ooey gooey slime. There are many recipes for slime. A common one uses white school glue. You'll also need water and a borax solution. Ask a grown-up to prepare this. Mix the glue and water in a bowl. Then slowly add the borax solution while stirring. You'll see the mixture start to thicken and become slimy. You can add food coloring to make it any color you like. Stretch it, squish it, bounce it. This is chemistry creating a cool polymer. How about writing a secret message with invisible ink? This one is super cool and uses a simple kitchen ingredient, lemon juice. Dip a cotton swab or a paintbrush in lemon juice. Write your secret message on a piece of paper. Let the lemon juice dry completely. The message will be invisible. Now, to reveal the secret, ask a grown-up to help you. Gently warm the paper near a light bulb or with a hairdryer on low. Be very careful not to burn the paper. The lemon juice will turn brown and your message will appear. Magic? No, chemistry. One more. Create a colorful rainbow in a glass. This experiment shows how different liquids have different densities. You'll need a tall, clear glass and several different liquids. Try honey, corn syrup, dish soap, water, and vegetable oil. Slowly and carefully pour each liquid into the glass. Pour them down the side of the glass to help them layer. Start with the heaviest liquid, like honey, at the bottom. If you do it right, the liquids will form separate, colorful layers. It's like a rainbow you can hold. Science is beautiful. Wow! We've learned so much about chemistry today. We've seen that chemistry isn't just some boring subject in a book. It's alive. It's happening all around us all the time. From the smallest atoms to the biggest stars in the galaxy, from the food we eat to the air we breathe. Chemistry is the amazing science that explains how stuff works. So the next time you see something change, like ice melting, or something new being made, like toast browning, think about the chemistry happening right before your eyes. The most important thing for any scientist is to stay curious. Always ask questions. Why does that happen? How does that work? What if I try this? Safely, of course. Keep learning about science every day. Read books about amazing discoveries. Watch science shows that make you say, wow. Visit science museums and try out the cool exhibits. The world is full of mysteries waiting to be understood, and you have the power to explore them. Maybe, just maybe, you'll become a scientist or an engineer someday. Imagine the incredible things you could do. You could discover a new medicine to help people who are sick. You could invent a new material that's super strong and super light. You could find new ways to create clean energy for our planet, or even explore other planets. The world needs curious minds like yours to solve big problems and make our future even brighter. Your interest in science today could lead to amazing things tomorrow. So keep that spark of curiosity alive. Don't be afraid to explore, to experiment, always with safety in mind, and to ask why as often as you can. Science is not just about knowing facts. It's a way of thinking. It's a way of discovering. It's an adventure that never ends. The universe is a giant, amazing chemistry set. Go out there and start exploring your part of it. Keep being awesome and keep doing science.